In linear algebra, scaling a vector is a fundamental and easy to understand operation. It's time to learn about it. In this episode, we will explore different aspects of scaling a vector, such as understanding it in algebra, in geometry, and also practice it using Python. So let's start in algebra. We can easily scale a vector with multiplying each element of the vector by a scalar. For example, consider a scalar like alpha and a vector like v. Alpha could be any number, and also v can be any vector with any dimension. Let's assume v is a 2D vector with elements v1 and v2. To scale vector v, as mentioned earlier, we can easily multiply alpha by each element of the vector. For example, if alpha is a number such as 2 and the vector v contains elements like 3 and 5, you can scale vector by multiplying the number 2 by each element, 2 times 3 and 2 times 5. But what happens when we scale a vector in geometric space? Consider this vector in this coordinate system, which starts from the origin and ends at the point 1 and 2. In this case, we want to scale our vector using beta, which is our scalar number. As we said, beta can be any number like 1.3. We need to multiply 1.3 by the components of vector, means 1 and 2. This operation will increase the magnitude of our vector. Let's test another value for beta. If we change beta to a value less than 1, such as 0.5, and then scale the vector, the elements in the vector will decrease in size compared to their initial values. But how does a negative value affect the vector? Consider a negative value like -2. When we multiply the elements of our vector by -2, the direction of the vector reverses, but it remains on the same line. Additionally, its magnitude increases. From these three examples, we can conclude that when we scale our vector, the vector retains its direction, while its magnitude increases or decreases or remains the same if the scalar is 1. It's important to note that the direction of the vector remains unchanged when scaling. Let's explore this further in Python. A scaling vector in Python is so easy to implement. To do this, first import numpy as np and also matplotlib.pyplot as plt. Next, I define vector v and alpha, which is a scalar. So simply say vector v is equal to np.array and use a list to define my vector. And the variable a, which represents the scalar alpha, is equal to 2. Next, I define a new variable named a_v, which is equal to the multiplying of a and v. In NumPy, you can use the asterisk operator to perform element-wise multiplication for scaling the vector v. As you can see, the result of scaling the vector is equal to 6 and 10, which is achieved by multiplying each element of vector by number 2. Before moving forward, let's consider what happens if I use a list instead of a NumPy array and use an asterisk operator to multiply a scalar with my vector. If I use a list and write a*v, I can see that it repeats the elements of the list a times, which is not the desired behavior. This happens because using asterisk in Python depends on the type of the variable. One reason we avoid using list in Python to represent vectors becomes evident in this situation. Okay, in the next step, I want to create a graph of my vector using Matplotlib. First, let's plot my vector. I will use the plot method from PLT. This will take the x and y coordinates to plot the vector in the coordinate system. Also, I will use several options to customize my plot. Use the marker option and set it to V to display the markers as triangles. And adjust the marker size to a suitable size for my plot, like 5, using the MS option, which is shorthand for marker size. Set the color to purple. And also set the line width to 0.5. I can use the LW shorthand for this. Next, I will add a grid to my plot using plt.grid. It's crucial to add labels to the axis of your graph for clarity. These labels should represent the data that each axis corresponds to. Therefore, I will set plt.x label to x and plt.y label to y. Another important task in graphing is customizing your x and y limits. Sometimes you may need to extend these limits, while at other times you may need to shrink the size of your axis. However, it's crucial to check these limits to ensure that your data is accurately represented on the graph. But first I will use plt.show to render my plot. While the vector is shown in the graph, it doesn't represent properly due to the unusual limits of my axis. I would manually adjust the limits of my axis. I can use xlim and ylim, but in here I want to use a new method, plt.axis, which can get different type of values. We can use axis method with no argument. In this situation, it returns the current axis limits as a tuple, which contains xmin, xmax, ymin, and ymax. In fact, it provides information about the limits of my axis. But to set limits, we can give axis a value which specifies how we want to show limits. If called with a list or a tuple, which contains xmin, xmax, ymin, and ymax, it set the axis limits accordingly. And if called with a string argument, such as equal, scaled, tight, auto, it adjusts the axis limits automatically based on the data and set them to predefined values. In here, I give it a tuple with specific numbers like -6, 6, -6, and 6. But if I change the coordinates of my vector, I need to adjust limits of my axis again to ensure that my vector remains within the limits of my axis. So there should be a better approach to setting the limits of my axis and configuring them automatically. So I set the x and y limits separately in their own variables. Set the xlim to first element of V and ylim to second element of V, which represent the minimum values needed to display my vector. However, I multiply them by a coefficient such as 1.3 to ensure they are slightly larger than the minimum values required. Then use these limits inside the plt.axis function as a tuple. So -xlim, xlim, minus ylm and ylm. It's work, right? But I should consider different scenarios and ensure my code works properly in each case. For example, my vector might contain a negative value like -3, which breaks my code. So I need to change my code. I want to always obtain positive values and then manually set them in my tuple as a negative or positive value. To achieve this, I use the absolute method to consistently obtain the positive values of the vector. Also, I know that my scaled vector is likely to be larger than my original vector. Therefore, I need to expand my limits accordingly. To fix this issue, first use max method to select the larger value between v and a_v. I know both of these two values should be positive, so I use absolute method inside max function. Now I can be confident that the x and y axes will always encompass my vectors. As you can see, my graph correctly displays my vector. Now I will add another plot to display the scaled vector as well. The scaled vector starts from the origin and ends in the endpoint of the a_v vector. I will use a dot marker in blue and plot the line as dashed. Additionally, I will reduce the line's width to make it smaller. I also want to make the size of the marker a little smaller with MS option. It's important to consider that if I don't use the double dash option, Matplotlib will only display my vector using a dot like this. But I want to show the line as well to observe the direction of the vector after scaling. Everything is working fine. However, I want to experiment with different scalars to observe how my vector changes as I scale it using various coefficients. To do this, I need to modify my code. First, I'll create a list of alpha with different values to use for scaling my vector. Then I'll use a for loop to iterate over these scale numbers and plot each scale vector on my graph. So I create a for loop with for I in range length of a to iterate from 0 to the number of elements in the a variable. Each iteration calculates the multiplication of the scalar with my vector and then plots the scaled vector. Additionally, it would be helpful to add some text annotation to the plot so I can see where my vector goes each time I multiply it with a scalar. So I use plt.text and give it x and y coordinates of my text and what I want to show. To show my text properly, I'll add a little space to the x coordinate of my text, something like 0.5. Also, I increase the line width of vector v to make it easily distinguishable. And there you have it. As you can see, scaling vectors does not change the direction of our vector. It only makes our vector smaller or larger, depending on the scalar. If the scalar is greater than 1, it enlarges our vector. If the scalar is between 0 and 1, it shrinks our vector. And if the scalar is a negative value, it reverses the direction of our vector. But as you can see, our scaled vector always stay along the same line. In fact, when scaling a vector, the direction does not change. It remains consistent with the original direction.